All right, so this is for general physics. This is the problem from your homework, exercise number 5. So we are going to need to use a couple more equations than F equals ma. If we look at this, let's look at the information that we know. We know that we start swinging the axe, so an initial velocity of 25 meters per second. We know that it's going to come to a stop, so that means our final velocity will be 0 meters per second. We know that it's going to travel a distance, which we'll use d for displacement, of 2.3 centimeters. Remember, here we have things in meters when we're looking at the velocities. Therefore, for our centimeters, we do have to convert that. So we want to put centimeters on bottom at our conversion factor, meters on top. 1 meter has 100 centimeters. So go through, you're going to take 2.3, divide it by 100 to find out how many meters this will be. And I prefer to go ahead and do this step right away so I don't forget to do it later. All right, so we also know that the axe head, oops, sorry, I misspelled that. When I typed it in, that should be axe, has a mass of 2.5 kilograms. I know I'm looking for a force, so ultimately my goal will be to use force equals mass times acceleration. Only problem is I don't know the acceleration here. I know the mass, and I'm of course going to be looking for force. So I would go back to the equations of motion personally, and I would use my position equation so that I could solve for my acceleration. I might need another equation as well. Let's get this all written out. So I know my initial displacement where it first touches the tree, that's going to be 0. I do have an initial velocity. I do have an acceleration. I do have time. I have two things here that I don't know. I do know this. I don't know these things. Remember, this is not 9.8. This is the acceleration that you're swinging your axe with. So I go and I find another equation that I have on my tool belt. So this one also has two things I don't know, but it works out well for me because I don't have any new unknowns between the two. So my unknowns over here are going to be acceleration and time. All right, so let's go ahead. I don't know if I can give myself much more room. I'll probably erase some things here in a moment. But let's take our displacement equation. We know that we're going to be displaced 0.023 meters. Our initial displacement was 0. Our initial velocity was 25 meters per second times a time that we don't know, plus our 1/2 times, I'm going to use the substitution method, and I'm going to plug in this stuff that acceleration equals and plug it in here. So I'm going to end up with my velocity final. Let's go ahead and actually put in the numbers on that. So my final velocity was 0, my initial velocity was 25, and the time I don't know. And then multiply that by my time squared. Now what I love about this, first of all, I've got a 0, don't have to worry about it. Second of all, I have a time downstairs, same time upstairs. I can cancel one of those out. So that means that this will simplify to 25t plus 1/2 of a negative 25t. All right, so let me give myself a little bit more room. Sorry for the delay. All right, I'm going to go ahead and get rid of this. You can always rewind on the video to see what I have erased. Okay, so here's the equation that I'm dealing with right now. Oh, looks like, well, okay. All right, so let's continue to solve. You guys know, I don't usually carry a calculator with me, but I've got 25 minus half of 25. Half of 25 is 12.5, so I got 25t minus 12.5t, which of course is going to equal 12.5t. Do a little algebra. Divide both sides by a number. We're going to get that the time it will take for the axe to stop will be 0.023 over 12.5. And in a rare moment, I have actually used a calculator. I get that that number will equal 0.00184 seconds. Now I want to know the acceleration, so let's go back to my acceleration equation and plug it in. My acceleration was going to be 0 minus 25 all over my time. I now know the time. So this is going to equal negative 25 over 0.00184. This is in meters per second. This is in seconds. So the answer that we will get out is 13,587, I rounded, meters per second squared. So we now know our acceleration. We know the mass, so now we can go and find the force. We plug in our mass of 2.5 kilograms times 13,587. Multiply those together, and this is the part I don't have a calculator for, so you're on your own, but I trust you to do this. And of course we have something in kilograms times meters per second squared. That, remember, the combination of units gives us a Newton. Now part B, how much force did the axe exert back on the tree? Use Newton's third law for that. You're on your own for part B.